the previous videos, we mentioned about the data acquisition system. It is basically a system comprising a series of measuring instruments together with a data logger used to measure, monitor, and record the data as acquired from the experimental program. Different type of measuring instruments has its own function, and the data logger helps to monitor and record the reading throughout the experiment. When we talk about the measuring instruments, we need to discuss also about the calibrations. Calibrations is the process of configuring an instrument to provide result within an acceptable range in order to maintain the accuracy. It involves using the instruments to test samples of known value, which is known as the calibrators, and the results are used to establish a relationship between the measurements technique used by the instruments and the known value. This process teaches the instruments to produce results that are more accurate than those that would occur otherwise. The instruments can then provide more accurate results when samples of unknown values are tested in the normal usage of the product. The basic ideas of calibrations is that you need to conduct the calibrations frequently. After a certain time of usage, the readings may slightly vary beyond the acceptable range. The purpose of conducting these calibrations is to increase the accuracy of the measuring instruments. Now the question is, how do we know that the instrument is accurate? You need something with the known value to be compared with the result as indicated by the measuring instruments. There will be corrections in the case that the variations occur between the measured result and the known values. It is not a process to rectify the instruments. In fact, it is more towards finding the relationship as compared to the known value, so that when you want to use the instruments to do measurements in future, the chances of acquiring the accurate result is higher. Therefore, every time when you want to use an instrument, always check the calibration history. Normally, every single measuring instrument will have a record of the calibrations. You can request from the technicians, or in some laboratory, the calibration record normally comes together with the instruments. You can check the dates of the calibrations as well as the due dates of the calibrations. If possible, you only use the instruments that the calibration date are yet to expire. In the case that you encounter the equipment which the calibrations is not done, or with the calibration record it seems that expired, and you don't see the intentions of that particular lab manager going for the next calibrations, and you are in the hurry, so desperate, require those equipments to be used in your investigation program, that means you will have to use it carefully. There are a few ways that you can do. First, you can try to work out yourself. Of course, it may not be as professional, but at least you have an idea whether the instruments is very significantly off from your known value. Or you can do some random check on certain known value in order to see the accuracy as a safety precaution, knowing that the instrument that you use should yield you the correct results. For example, you have a load cell having the capacity of 300 kN. You're not sure, or you just want to confirm the accuracy of the reading. You can put some weight onto the load cell, probably carefully stand on the load cell, as you know the weight of yourself, and to observe the reading. Is the reading correct? To which degree the accuracy? Or you may use several load cells, testing over the same known value in terms of the weight. Find the average. Choose the one closest to the average. This is at least you are confident with your results. And this is provided those measuring instruments are not significantly off from the actual results. At least something that you can do for you to gain confidence of the measuring instrument is that after you acquire the results, realize that they are different from your background knowledge or your fundamental understanding. Then you start to be suspicious whether your measurement is correct, or is it really due to some unknown factors that leads to different outcome than what you expected. In terms of the calibration frequency, normally they classify it into critical instruments or non-critical instruments, as defined by the labs. For the critical instruments, normally the frequency will be higher, and for non-critical instruments, the frequency will be lower. This is of course subjected to the budget that the respective lab has allocated for the calibration purposes. The factor affecting the calibration frequency involve the age of the instruments, how often the instruments is used, who is using the instruments, environmental conditions where the instruments is stored and used, type of the materials the instrument has contacted with, and required uncertainty in measurements. These are the circumstances that calibration frequency may increase. Any instruments is found out of tolerance limit during the routine calibrations. Any errors in the measurements by instruments or device could lead to quality issue or batch of any safety issues. Any instruments is being used in a critical process where an error in result may cause any harm. It is more related to the needs of accurate result, which is normally associated with the impacts or the significance of the results, as well as the historical performance of the instruments. For example, after several times of routine calibrations, the equipment seems to be quite accurate. That means most likely the frequency may be reduced. Or every time when you do the calibrations, you realize that it's always out of the tolerable limits. That means most likely you will need to reduce the gap between the calibrations. The calibration frequency can be decreased when the calibration results are found with the specific limit during the calibrations from a long period of time. That means the instrument shows a good reliability even after a long period of time, and also the instrument is used in any non-critical process. That means it is not that critical, and the lab will like to save budget for the calibration purpose. You know that calibration process is a specialized process which requires specialized personnel, and it's going to cost money. Imagine in a lab there are so many measuring instruments. It is nearly impossible to have all the instruments fully calibrated within the recommended period of time. And you also know that for some established university, research activity is very active. Postgraduate students will need to use those measuring instruments year in, year out. Of course, it is possible to have the equipment being hauled or retained for a short period of time for the calibration purposes. This may also affect the progress of research work of the postgraduate students. Practically, there are many considerations preventing the entire lab to have all the equipment fully calibrated and every time calibrated on time. Therefore, if you choose to use the instruments, you have to use it carefully. Always do some quick check until you are confident with the results. At least you know that the result is within the acceptable tolerance. Then you adopt it in your research program.